Hi there, and welcome back to the AI Developer Bootcamp. My name is James, and in this module we're going to be talking about how to build bots using the Microsoft Bot Framework. In each of our sessions in the AI Developer Bootcamp, we're going to try and start by asking some fundamental questions that we want to be able to resolve by the end of the session. For this session on bots, we're going to ask two questions. How do I build a bot? And how does it understand what I ask it to do? We're going to spend this session finding out. So, why are bots interesting? Why have these suddenly become such a popular topic in our industry? If we trace back the different ways that people interact with computers, they started off on the desktop back in the 80s and the 90s. In the late 90s and into the 2000s, they moved to the web browser, and instead of starting applications, they visited websites. Then, with the rise of the smartphone, we saw the rise of the App Store. So rather than going to websites, people would go to an app store, download an app, and use that to interact with their favorite service. What AI is unlocking is a new form of interaction, which is often referred to as conversation as a platform, or bots. And in this form of interaction, people simply express natural language queries to systems. For users, this is a real shift. No longer do they need to learn a new pattern of interaction, whether it be the web or apps. They can use skills they already have. So in this case, applications are augmenting human ability rather than forcing humans to fit into a predefined paradigm. So why are bots useful to us? Well, they allow us to interact in a variety of different ways. We can type messages, we can talk to them, we can tap on them. And we can expose these bots in a number of different ways. We can surface them through common tools like Facebook Messenger, Cortana, or Skype, which makes them much easier for users to interact with because they're already using these technologies. They're already present in these channels. So what fundamentally is a bot? Well, a bot is one thing. It's an app that performs an automated task. And one of the early bots we've already talked about, that's Clippy, the Microsoft Office assistant. It solves a user's requirement, a user's task, as quickly and simply as possible. So that means that bots are not going to be the right solution for every problem. A bot in and of itself doesn't actually require any kind of AI. It doesn't actually need to use natural language, and it certainly doesn't require voice. However, certainly these capabilities can make a bot potentially more attractive. So when we think about building bots, what do we need as developers? Well, we need a way of structuring the conversational logic and our business logic. We need to be able to make the bot aware of the different canvases that we want to interact over, whether it be Cortana or Skype or Facebook. We need to make sure that the bot is aware of the context so it maintains its understanding as the conversation evolves. And we'll also need a number of tools. If we want to use natural language, we're going to need services for that. If we need the bot to be able to recognize images, we're going to need AI services for that as well. The framework that Microsoft has put together makes doing all of this really easy. All we as developers need to do is build a simple web service. There's an SDK available if you're developing in C# or Node.js. However, because the interface is so simple, we're literally just receiving a JSON message, it's conceivable that we could implement this in any language via any endpoint that's publicly accessible. The Bot Connector service is one of the key parts of Microsoft's bot framework. And this service allows us to ignore all of the complexity that's involved with integrating into various bot channels. We don't need to understand how to connect to Facebook Messenger. We don't need to understand how to connect to Teams or Cortana. All of this complexity is hidden by the Bot Connector service. Our code simply gets a plain JSON message. Now, to make our bot more interesting, whether it's to process natural language or to understand an image, we can rely on the Microsoft Cognitive Services. And a number of these are integrated directly into the Bot Builder SDK. And then finally, we're likely to require other platform services, which makes Azure an ideal place to host our application with its databases, machine learning capabilities, search, and more. So they're the key components of the bot framework. We have an SDK that allows us to quickly build a RESTful endpoint that can process messages that our users send. We have a developer portal that allows us to configure and work with the Bot Connector service. And finally, as we've already discussed, we have a range of cognitive services that allow us to understand people and their content. So let's actually have a look at some code now. Let's see how easy it is to build a simple bot using the bot framework. And as you can see, all of the code that we need actually fits on a single slide. If you've built with Microsoft.NET and the Web API framework before, a lot of this will look very familiar. All we're doing is building an endpoint in Web API that accepts a message of type activity. These messages received from the Bot Connector service are sent for various events. We will receive a message every time a user sends something via the channel. We'll also receive messages when they join the channel or leave the channel, or potentially even when they start typing. And all this code does is that if it is a message that has some text in it, is that it's going to echo that message back to the user. It's not a particularly useful bot, but it shows you how little wire-up code is actually required to get started. So we've talked a lot about the messages that we receive from the Bot Connector service. Let's take a look at an example message. As you can see, it's formatted in JSON and easy to work with. What you'll also notice is that it's not a message type that is specific to the channel that the user chose to interact with. So the code that we write doesn't have to worry about the complexities of the various channels that our users might be using. So now that you've finished your web service, now that you can accept and process the JSON messages that are being sent to you by the Bot Connector service, you need to decide where to host this logic. The only requirement from the Microsoft Bot Framework is that the endpoint is publicly accessible. So there's no reason you couldn't actually host this on an on-premises server. You could even add it to an existing web server that's running in the cloud. One of the key characteristics, however, to consider is that this is a highly event-driven architecture. That means that the bot is only going to be doing any work when a user sends them a message. This makes a serverless hosting environment an ideal candidate for hosting your bots. And on Microsoft Azure, the solution to serverless is Azure Functions. Fortunately, Microsoft have already identified this and prepared the Azure Bot Service. The Azure Bot Service is a combination of the bot framework, that is the Bot Connector service, the SDK, and all of the channel integrations, with Azure Functions. So via a single item in the Azure portal, we can not only host all of our logic, but also connect it to our bot endpoints. So we get the benefits of both of these services. We can develop in Node.js or C#. We can integrate with all of the same types of bot channels. We can pull in cognitive services easily because we're running in Azure. And thanks to the power of Azure Functions, unless somebody is chatting with our bot, we're not having to pay for any hosting. And similarly, as soon as we get popular, Azure Functions will seamlessly scale out the compute required to answer all of the requests. So now let's switch over to the demo machine and have a look at how easy it is to create a bot using the Azure Bot Service. So let's jump into the Azure portal and see how easy it is to get started with the Azure Bot Service. We click on New, we search for Bot Service, and we'll click on the top result. Creating a bot service is really easy. We need to specify a name, a resource group, and a location. There's really only one decision that you need to make, and that's how you're going to host your app. Now, by default, it selects the app service plan, and this uses traditional app service hosting mechanisms. So this is effectively a website. So you're going to provision one or more pieces of hosting hardware. Now, if you already have app service plans in production, you can actually host this application on the same hardware. The other option is a consumption-based plan. This is Azure Functions under the covers. So this means you're only paying when the bot is running. And when the bot is not responding to a customer, you stop paying. So let's see what one of these looks like in action. I've already provisioned one that uses the consumption-based plan. So let's continue and have a look at that in a little bit more detail. Once it finishes provisioning, you're going to have to do a couple of additional steps before it's actually ready to go. The first decision that you're going to be presented with is to select a template for your bot. You can select either C# or Node.js. Now, you can override all of the code with your own materials. This is just a starting set, so the bot by default does something. The next thing that you need to do is create a Microsoft App ID and a password. So to create the Microsoft App ID and password, I just have to click this button and it will take me to the App Developer portal. It's going to automatically create an application for me with the same name as my bot. However, there is one step that I have to do. Once the application has been generated, I'm going to click on this big button here and it's going to generate a password for my bot. Now, it's going to automatically pre-populate the app ID part for me. However, it can't pre-populate the password for me. So I need to manually copy this to clipboard and paste it back into the Azure portal. So I'll click Finish. And you'll see that the app ID immediately appears in the Azure portal, but I need to paste in the password. I then agree to the terms and conditions and click Create. And in the background, this is actually going to do another resource manager deployment. It's going to deploy things like a storage account to store my code. It's going to deploy an App Insights subscription to monitor the usage of my bot and a few other things. So we can let that one proceed in the background. And we can go and have a look at a couple of bot services that are provisioned in advance. The first one I'm going to look at is one that runs on Azure Functions, like the one that we just finished provisioning. When I open this in the Azure portal, you'll see an interactive developer experience. So I can actually start writing code right here in the portal. One thing to be aware of is that all of the code files end in CSX, which means that they're dynamically compiled C# code. That means if I make a change in this browser and press save, it will immediately apply and become available via my bot endpoint. I can even interact with my bot directly from the portal. If I open up the test window, I can send a message. It greets me and then it echoes that same message back to me. It's a very simple bot by default. Other key parts of this portal include the Channels tab, and this shows you all of the different ways that you can expose your bot logic. You can expose it as a Cortana skill, as a website, as a Facebook Messenger plugin, as a Teams bot, and many more. You can also take advantage of the Direct Line service, which allows you to build a fully custom experience for the front end of your bot. And that's in fact what we did for the Litware Insurance website. Other tabs include Analytics. This is using App Insights to identify the number of users and the number of messages that your bot is receiving. Because this is the new bot, there's very little data here. And then the final tab, Settings, has a bunch of important things that I'd like to point out. The first one is Advanced Settings. If you click open there, you'll actually see the app service that powers this bot, So you can do all the normal things that you would expect to be able to do with an app service, including restart it, adjust diagnostic settings, and more. Right at the top, there are your options for continuous deployment. So you can actually download the code that is pre-populated or that you've edited from within the browser window, check it into source control, and then set up a continuous deployment pipeline. And as soon as you establish that connection, you can no longer edit it from within the portal. You can also configure your bot, including right down the bottom, adding co-owners. And this is an important step if you're going to be working in a team environment. Not only do you need to grant co-developers access to the bot service itself through traditional Azure Resource Manager, you also need to grant them access via this portal as well. This, in fact, is the bot framework part of your bot, and granting access via the Azure portal is the Azure part of the bot. So they're the key parts of a bot service. Let's close this and let's take a look at another bot service. And this bot service is actually running on an app service plan. So I've actually spun up a basic level 1 hosting environment here to run this. So I'm going to be paying for this regardless if I'm interacting with the bot or not. And you'll see immediately there are a couple of differences. If I want to work with this particular app, I'm actually going to have to open up the Visual Studio Online editor to edit my code. But beyond that, everything is the same. I get the same flexibility in terms of the channels that I expose through, I get the same analytic overview, and I have the same options in terms of settings. I can go into the advanced settings and manage this like any other app service that I might have. So that's the Azure side of things. Let's go and have a look at what's involved in running a bot locally so we can start debugging and developing our application. So if you download the code from the Azure portal, if you download the dynamically compiled code from a functions hosted bot service, you'll get a solution that looks a little bit like this. It's actually a little bit unusual if you're familiar with Visual Studio because there's no project structure, there's no web project, there's no class library. All of the files are simply there as solution items. And in fact, this is because it's an Azure function. It's dynamically compiled. When we start debugging, it will just simply add in the files that it finds and compile them. So that means working with this is a little bit different than normal projects. There's no project to start, there's no project to start debugging on. To work with this project, we're going to need a couple of extensions. We're going to need to install the Azure Functions tooling, and that's available from the Node Package Manager via the Azure Functions Core Tools package. And we're also going to need an extension for Visual Studio, and that one's called the Command Task Runner. And the Command Task Runner allows the application to recognize that this is a Azure Functions hosted set of code and automatically start a debugging host for us. We can see the Command Task Runner here. Now this will work in both Visual Studio 2015 and Visual Studio 2017. So once we've got that Command Task Runner installed, we can open up the Task Runner Explorer window, and we can actually see the bot immediately start to run. It will dynamically compile all of the code and expose it as a web endpoint. In this case, we can see the URL in line here. So if we want to debug this code, it's already running, so all we need to do is attach a debugger rather than start something from scratch. So let's do that. Let's show how easy this is. So we can open up one of the C# files. Now, one thing to be aware of is that sometimes Visual Studio won't actually load all of the necessary IntelliSense on the first load. So if we open up the file again, there we go. All of the colors come back. And I'm going to put a breakpoint right here when we receive a message. And then if I click Start, it's going to attach to that existing running process. Now, how do I interact with my bot? Well, the easiest way to interact with the bot is using the bot emulator. And this is an open source tool that you can install locally. And this is actually a fully simulated offline version of the bot framework. So it handles all the state management, and you don't actually need to have any kind of network connection to be able to test your bot. So the first thing to do is simply to enter the URL that you received in the debugging output from the Command Task Runner and click Connect. We're now connected to our locally running bot. And if I send a message, for example, hello, we'll see that our breakpoint is hit immediately. If we continue through, we see the message is responded to by the bot, and all it does is echo that message back. Now, if I send another message, if I send hello again, we hit the breakpoint, but something slightly different happens in the bot emulator window. We actually see that the counter next to the message increments. So let's go and have a look at the code behind this. If we open up the echo dialog, we can see the code that's actually responsible for responding to our message. And we can see that it's maintaining the count on a field on the class. So on this echo dialog, there's a property called count that's maintaining it. How is this actually doing that though? Because as we've discussed before with Azure Functions, between each request, all of this actually goes away, right? Azure Functions are only running when a message is received. What's actually happening here is that the entire dialog is serialized between requests, and that's why you'll see the serialized tag on dialogs and other classes within this solution. So that means on the very first time that the conversation starts, a class of echo dialog is created. And then after that first response is made, it is serialized and stored. The object is then deserialized on the next request rather than a one created from scratch. So we can actually store state on the class. Now this uses the .NET Binary Serializer, a serializer that has been part of the framework for many years now. It is not capable of serializing all different types, but the bot framework is quite good at providing useful error messages if you try and add types that are not serializable by the binary formatter. So that's us debugging locally. How would we go and debug with Facebook Messenger or one of the other channels? Well, right now we're running entirely locally, and unless Facebook releases a local Facebook simulator, we're going to need a way of exposing this service to the world. So the easiest way to do this is via a free tool called ngrok. And ngrok allows us to expose an endpoint on the web that then proxies back to our local machine. And it works around firewalls and the like, so we can run it really from anywhere. So in this case, I'm going to start ngrok. And I've already got a configuration set up within the system and a domain name for my bot. So now I have a public web address that my bot can access. So that means when I start to interact with another channel, it's very easy to access. I don't have to open up firewall ports or find a publicly accessible IP. So what I'm going to do with this particular bot is expose it to a chat program called Telegram. Now, one of the things that you might have seen in the Azure portal just a few moments ago is that there's a field that defines where the bot should send all of its messages. So when a message comes in from Facebook, where does that message get passed for execution? Where does your code live? Now, when your bot is hosted in Azure, that's an Azure endpoint, but for local debugging, we need to be able to point it to a local endpoint. So in that case, we can go directly to the bot framework, which is dev.botframework.com, and create a bot registration without any of the associated Azure pieces. And that's what I've done here. I've created a local bot registration. And once you create a local bot registration, you can actually update its configuration to point to your local endpoint on ngrok. So this bot will never run unless I am debugging locally. So to add an additional channel, I'm going to go to Telegram. And to add Telegram, I need to provide a credential, which I have already signed up for on the Telegram site. So I'm going to copy that. And I'm going to paste that into the bot. I'm going to click Save. And now my bot is available through Telegram. So if I return to Visual Studio, I place my breakpoint, I click Start. I've had to change no other code. This is just configuration in the bot connector service. So let's switch over to the Telegram app that I have installed locally and connect to our bot and see how we can debug through this. If I click Start, I immediately get a message from the Telegram bot. So that message has gone from Telegram, it's gone to the bot connector service in the cloud. The bot connector service has been able to take my API key that I've just provided it, to retrieve that information. And now it's sending the message on to the endpoint that I specified at the bot framework portal, which is my ngrok endpoint. So the message has gone from Telegram to the bot connector down to my local machine. And now at this point, I can debug and work with Telegram as a channel. Let's get back to the slides. So we saw how easy it is to create a bot using the Azure Bot Service. But that bot was relatively straightforward. All the bot was able to do was respond to the user with the message that they had originally sent the bot. Any bot worth its weight is going to need a more sophisticated conversation pattern to engage its users. And there are a range of different approaches that we can adopt to make that happen. By far, the easiest approach is to use a service like Q&A Maker, which we're going to talk about in a later module. That simply allows the bot to respond to commonly asked questions. To capture data, like we did in the Litware insurance scenario about the make, model, and year of the vehicle, we can use a technology called FormFlow. To build more sophisticated patterns of interactions, we can use dialogues, or we could even roll the entire experience ourselves. Let's talk a little bit more about FormFlow and how easy it makes capturing data from users via a bot. You can think about FormFlow as data binding for bots. You may be familiar with different UI frameworks like XAML or Angular. All of these have the concept of data binding. So any user entered information is automatically reflected in the underlying model. FormFlow does exactly the same thing for bots. We're able to define plain C# classes and that the bot framework generate an interface via the bot channel. So for each property on the class, it will ask the user to provide information, and then it will insert that information in the underlying field. It also handles other operations for us. For example, it allows the user to exit the flow, it allows the user to ask for help in completing various steps, and the user can also insert instructions to go back and update previous responses. Now, the experience that the bot framework builds for you by default is fairly straightforward, but we can make it a lot richer by applying attributes to our code to override things like how the bot asks questions. We can even extend it further by writing our own code and become very prescriptive about how that experience is generated. We can build things like carousels, we can add advanced validation logic, and much more. So that's FormFlow, and we're going to see a demo of that in just a moment. It's a key part of any bot experience. The next concept that's really important to recognize are dialogues. If you think about a traditional application, it has many screens or many dialogues to take you through. For example, if you are opening an ordering application, you might start on the main screen. The next window might be a product order screen. And then from that product order screen, you might have a product lookup screen to select which product that you want to order. The key concept here is that with each screen, the user can do different things. They can't do everything from a single screen. So we can constrain the actions of the user to simplify the experience for them. It also allows us to better componentize our code. Bots have a very similar concept in dialogues. Dialogues allow us to group our code together and restrict what a user can do at any point in the flow. Let's take an example of this to make it a little bit more concrete. The example here we have is a banking bot, and this banking bot allows you to do one of two things. It allows you to make a payment or check an account balance. And you can do this from the main dialog, the home screen. As soon as you select one of these two options, like make a payment, we start a new dialog. And this new dialog allows you to do only a few things which are relevant to payment creation. We now ask them a question, and that response the account number, is processed by the Make Payment dialog. The Make Payment dialog is aware of these concepts, unlike the main dialog. Once the payment is complete, we return the user to the main dialog. They can then start another flow. In this case, they're going to check their balance, and unsurprisingly, we start the check balance dialog. So any instructions issued are processed by this dialog now. We may even start another dialog that could be specific to the current account balance check process. Now, dialogs can quickly get complex, as you can imagine. And users won't always understand this concept. Unlike in an application, they don't visibly see new pages or dialogues pop up. This is something that is transparent to them. So while this does allow us to simplify our code, we have to be aware that we are dealing with people, and people can ask unusual things at any point in the conversation, not just when we would prefer them to. So that's how we structure the conversational logic. We use form flows and also dialogues. The next thing to consider is how we present these kinds of questions to the user. What kind of mechanisms do we have to make this engaging? The example that I have on screen right now is Facebook Messenger, and we've sent this particular customer from our bot a notification that their flight is delayed. It's a plain text message. It's very easy to implement a solution like this. However, it's not particularly engaging. It doesn't look like a native experience for the user. Another way of doing this would be to use a native capability of Facebook, and that is Facebook Cards. Here we express exactly the same content, but we do it in a way that looks native to the platform and is a much richer experience to the user. We have a number of different mechanisms to make this possible through the bot framework. The first is to let the bot framework take care of it. It has a number of built-in capabilities that if you provide sufficient metadata about the information that you're sending to the customer, it can actually render it in a platform-specific way. To give you an example of this, when we looked at the Litware insurance demo, it asked us what kind of insurance we wanted, and it presented a carousel of options. Now, if we asked exactly the same thing via Skype or Cortana, the bot framework would be able to translate that into a platform-specific carousel option. All we need to do is provide the metadata that's required, and the bot framework handles the rest. So that's the first step. We can also generate channel-specific responses. Now, this does complicate our code. That means for each channel that we support, we need to specify how it should render the card. And then finally, a new technology that has been released by Microsoft are adaptive cards. This gives us a generic cross-platform markup language to describe how we would like our cards to look. This gives us a little bit more control as developers over the look and feel of our cards. So what kinds of cards can we send to our users via our bot? Well, the bot framework has built-in support for a whole bunch of different options. You can send hero cards, you can send animation cards, you can send receipt cards for payment scenarios, you can send sign-in cards if you need people to authenticate before proceeding. The bot framework has a range of different experiences that are available to you as a developer right out of the box. In addition to cards, they have other ways of communicating with your customers. In addition to text, you can send images, video, audio, and more. It also has a range of different options to allow prompting the user for input. For example, buttons, lists, and carousels. And it also has inbuilt support, for some channels at least, for speech to text. And that will allow a user to use their voice to interact with your bot. One of the more recent additions to the Azure Bot service is a tight integration with the Azure App Insights service. This, by default gets provisioned as part of your bot service and wired up. And it gives you immediate insight into who is using your bot and how they're interacting with it. Let's have a look at this in action by switching to the demo machine and showing you how to use some of the technologies that we've just discussed. So before we get started looking at forms and dialogues, I want to show you one of the changes that I've made to the solution. Now, if you look in Visual Studio, you'll actually see that it's no longer a dynamically compiled C# project. One of the challenges with dynamically compiled C#, at least at the moment, is that the tooling support isn't great. You don't get IntelliSense, which makes development a little bit more painful. So instead what I've done is I've taken advantage of the great Azure Functions tooling that's been added to Visual Studio recently. And I've just created a pre-compiled Azure function. Now, to move the code from dynamically compiled C# to normal .NET code is super straightforward. There are very few changes that you need to make. You need to add some namespaces back in and add a few of the necessary attributes for a pre-compiled Azure function. But aside from that, the code itself, as you can see down here, is unchanged. I will point out though that in the current version of the SDK that I'm using, there is a bug where certain assemblies are not found at runtime. This has been logged on GitHub, there's a workaround available, and it's actually fixed in the code base. So in the next release, this won't be an issue. But if you run into some unusual assembly resolution errors, that's the place to go to understand how to fix them. So with that said, let's go on and have a look at forms and dialogues. So if you remember back to the Litware Insurance demo, one of the first things that I had to do was tell the bot about the vehicle that I wanted to insure, and it asked me about the type, the model, the make and the year. So how did we do that? Let's go and have a look at how we can use the FormFlow SDK to actually build this experience. So if you have a look at the C# class that I'm showing you now, and I'll zoom in slightly here, it is actually a plain C# class. If you ignore the comments, it's just got 4 properties on it. A car type, which is sedan, SUV, or sports car, and that's an enum, and it's got 2 strings for make and model, and then an integer for year. Now, if we pass the type of the model, which is a car, to the form builder class, and then call build, that will actually do all of the reflection over that class and generate an interface for us. And then once the user has finished entering these properties, we'll get an instance of this class with all of the data that the user has filled in. So it's a super useful piece of technology to help us capture data. So let's see this in action. We'll click Start, and because this is a pre-compiled Azure function rather than dynamically compiled stuff we were looking at before, we debug it in a very normal, expected way. We don't have to use the command task runner. It'll just start up once we click Start. So now that it's running, we can connect to it in our emulator in exactly the same way. It surfaces itself up under the same endpoint. And I'm going to type in, I need insurance, just like we did in the demo. And it's going to generate a user interface based on those 4 properties on that class. We'll see that they haven't got that quite right yet because SUV has the wrong capitalization. If I select sedan, I get asked to enter the make, which is fine. Get asked to enter the model, which is a Fusion, and then I get asked to enter the year. And it phrases this slightly interestingly. It says the current choice is 0, but no matter, we can provide an answer to that too. And then it provides this little summary, which we didn't really need, but we have it anyway, and then we have to confirm. We can say yes, and then the flow ends. So this isn't a great user experience. So how do we make this better? Well, the first thing we can do is add some attributes to each of the properties. So for example, we can override how it asks what kind of car it is. So rather than saying, please select a type, we can actually get it to say, what kind of car is it? We can override the help text. We can override even validation. For example, for the year, we want something between 1900 and 2017. That can get us quite a long way, just decorating our properties with attributes. But if we want to take things slightly further, we can actually write code. And that's what we've done here. So after we pass the type as a generic parameter to the form builder, we can fully customize the interface that gets generated. So we're going to add the car type field first, and then we're going to add the make field. Now we're actually going to override this in a little bit more detail. We're going to override some validation logic, and this is fairly pointless validation logic, but what it's actually going to do is that if you specify Ford, it's going to reject that and force you to prompt and answer again. And we're also going to override in code how it asks this particular question. And we're actually going to give it two different options, so it can choose which one to apply. It makes it slightly less robotic if it can ask the same thing in different ways. We can then add all of the remaining fields using the default experiences that are provided by the bot. And then we add a message that it shows right at the end, thanking the user for their data. The last thing that we're going to do is then attribute to the SUV option, and that's going to capitalize it correctly in the user interface. So let's see the difference that we have as soon as we add this in. So if we go to the bot emulator, reconnect and reissue the command, I need insurance. First off, we can see that the pick list that we're presented to select the car type has the right capitalization for SUV. Rather than saying, please enter make, it now says, what make is it? I'm going to say Ford. In this place, my custom validation logic is going to run and reject that answer. So it's going to ask me again, and I can say Contoso, for example. Then I'm going to enter a model. And then I'm going to enter a year. And again, it doesn't say it quite the same way as before. It doesn't say current selection 0. It actually provides a more intelligent phrasing because that's what we specified. Enter 2011, and then it sends the thank you message that we specified, and then the flow ends. So that's a really easy way to capture data from users using the FormFlow SDK, which is super extensible, so you can really tweak and customize the experience that your users receive. The last thing that we can do to make the experience even richer is to provide some additional metadata to help the bot framework render the choices that the user has a little bit more richly. So to do that, to highlight that functionality, we're actually going to add something to the flow. We're going to add the prompt for the type of insurance that the user is interested in. If you remember back to the original LitWeb demo, we got a little carousel with a few different options, whether it's car insurance, life insurance, or property insurance. Now, the interesting thing about that situation is that depending on the user's answers, we might want to start a completely different flow. If they select property insurance, we're not going to be asking them questions about the kind of car that they're wanting to insure. We're going to ask them property questions. So one way of doing this is using the chain functionality that exists in the FormFlow SDK. We can actually make decisions and then choose different forms to present depending on the user's answers. And that's what we're going to do here. We're going to create first a form based on this simple class here, the insurance type class. Simply has one property called name. And then if once this form flow finishes, the user has provided car as the answer to the type of insurance, then we're going to continue with the form that we just finished building. If they provide something else, we're going to quit and terminate that flow. So if we have a look at that now, we're going to jump into the channel emulator. We're going to restart that. I'm going to enter the same phrase, I need insurance. And it's going to say, please enter name. And again, because it's reflecting over that class, that's the best that it can do. It's not able to generate a carousel or a more interactive experience. So how do we build that carousel? Well, we just have to give the bot a little bit more information about the data that we're wanting to collect. And we can do that in a similar way as we overrode the validation logic in the case of the model. So in this case, we use the setDefine method, and this gives us complete control over redefining how the bot prompts for this particular field. We can set a new prompt phrase, and then we can add a set of options to the bot. We can add a description for each of these options, including an image. Now, we haven't explicitly said to build a carousel here. But by providing this additional information to the bot, providing a set of choices for the users to select from, it can recognize that this is a suitable place to render a carousel. And this is really cool because we haven't actually made this specific to our website or specific to the emulator. If other channels like Skype support carousels, it can take this same data and render a carousel there as well. So let's start this and see the difference. We'll return to the emulator, we'll restart our conversation, we'll enter our magic phrase, I need insurance, and we get a carousel now. We get images as well as text and buttons for the user to be able to respond quickly. Let's get back to the slides. So we just saw how you can build conversational logic in your bots using form flows and dialogues. And before we jump to the next section, I'd like to quickly review some common patterns and anti-patterns that are important when building bots. The first anti-pattern that I want to start with is a canvas mismatch. The example that I've got here is somebody trying to play a first-person shooter game via a bot. It simply doesn't work. That kind of pattern of interaction is much better left to a game console controller. Now, this is a fairly extreme example, but you can imagine others that run afoul of this rule as well. For example, a complex form is probably not going to be a great thing to expose via a bot. Imagine filling out a multi-page tax return in question and answer format. Traditional interfaces are probably going to give you a much better user experience. The next anti-pattern to consider is an overuse of natural language. We're going to talk about a number of different technologies today that help you process natural language. However, it's important to recognize that people speak in a variety of unusual ways. And over-investing in natural language can be detrimental to the overall impact of your bot. For example, I have a quote here from a theoretical user who is looking for a house, and they specify all of the details, including the price, the garden, the square footage, and its location. Very few people speak in this way. We could process this with natural language. However, we'd be much better to invest in simpler natural language processing and be able to recognize statements that are simpler, like I want a house. Once users enter statements like this, then we're actually going to be better to guide them through the next set of questions with interactive experiences like buttons and carousels, rather than continuing to force them to express themselves through natural language and risk us misinterpreting them. A couple of patterns now to keep in mind when building bots. The first one is the back channel. In many cases, for example, a website, our users are not only going to be connected via the bot, they're also going to have a connection via the website. The bot framework actually allows us to share data on the back end. So that means as the user navigates through our website and retains that connection to the bot, we should be able to use that information that we're capturing to inform how the bot responds. So if the bot is looking at a particular product or service, we can actually send this information to the bot so it can use this to respond to the user's queries. The last one that I want to talk about is the concept of global handlers. As we mentioned when we talked about dialogues, sometimes users don't necessarily send instructions in the way that we might expect. They might be halfway through checking their balance and then suddenly decide they'd like to talk about a mortgage. Global handlers help us handle that situation. They allow us to use the iScorable interface and pass the same message to multiple dialogues. And then the dialogue that matches the best can respond to the message. The final pattern that I want to talk about today is the handoff to human, and we saw this in the Litware insurance demo. There are a couple of concepts to consider here when building your bot. The first is that it's not necessary for your bot to be able to handle every situation if it has a mechanism for handing off to a human agent. The other thing to consider, which we also saw in the Litware insurance scenario from the CRM portal, is that the bot can continue to assist the agent, even though it's no longer interacting directly with the customer. It can provide pre-populated responses or even make recommendations to reduce the work that the agent then has to conduct. So, we've talked a lot about natural language so far. Now it's time to explain how we can use this in the bot framework. Natural language is hard, and it's been hard for a long time. And it's hard for a number of reasons. First, it's very technically challenging. Language is not something that is easy to understand or parse with traditional computer technologies. It's often also costly to implement because of the investment required in the machine learning systems that underpin it. And then finally, even if you're able to find an off-the-shelf machine learning model capable of understanding natural language, typically the bot that you build will be for a specific domain. That means there will be domain-specific language and terms and concepts that a general purpose model simply won't get right all of the time. So for all these reasons, natural language has typically been something that were avoided as software developers. However, it's hard to avoid that when you're building rich interactive bots. And Microsoft have solved this solution with a technology called the Language Understanding Intelligence Service. It's part of the Cognitive Services platform, and it's more commonly known as LUIS. LUIS makes it really easy to get started with natural language in your bots. First, you train it. And training is as simple as providing examples of how your users will interact with your application. For example, when we worked with the Litware insurance demo and we asked for insurance, there are a whole bunch of different ways that we provided to LUIS to ask that question. LUIS is then able to take that information and build a model around it. So if somebody comes along and asks that same question, but in a slightly different way, it can still recognize it as the same inquiry. Once the model is prepared, it can be exposed as an HTTP endpoint. The bot framework, however, has an out-of-the-box integration with this service. So we don't even need to call the endpoint directly. And we'll see that in the upcoming demo. And then finally, the service has a lot of rich analytics built in. So we can actually understand whether the model is weak or whether customers are entering queries that are not matching any of the model's rules. So LUIS fundamentally is actually quite a simple service to get started with, as long as you understand two concepts, intents and entities. The best way to understand intents is through a few examples. Here are 3 examples of queries that our users may make to our bot. And you'll notice that I've got some blank spaces in here. So rather than having the intent as, who is John, I've got who is blank. This is the intent of the user. If I fill in these blanks with the specific people that the example is referring to, who is John, where does Sue work, what is Erica's phone number, these specific examples are the entities. So it's the intents that drive the code that calls in the background. It's the intents that trigger the response from the bot. But it's the entities are the effective variables in this equation. These will be passed into the logic and then ultimately passed through to the line of business system that we need to call to build a response. So if you understand intents and entities, then you understand LUIS. In the example along the left here, we can see what is Dan Driscoll's title. Well, what is somebody's title is the intent. Dan Driscoll is the entity in that intent. However, despite that being fairly straightforward, Microsoft makes it even easier to get started because they have a whole bunch of pre-packaged intents and entities that you can take and build a model really quickly. So if you're building an app in a particular domain, perhaps you're building a camera app or a fitness app, they have a whole bunch of pre-trained content that you can simply load into your model to get started. Similarly, they have a whole bunch of inbuilt support for recognizing really complex concepts. For example, expressing dates and times is quite sophisticated when it comes to a natural language processing perspective, and they build that into the platform for us. Right now, LUIS supports around 10 languages, and this is expected to grow over time. As we mentioned, LUIS has built-in support for continuous improvement. You can identify how frequently people are interacting with your service, which entities and intents are the most popular, and also, critically, when the bot is not able to match an intent. So you can take that data and improve your model in the future. Finally, you can also export and re-import your model as JSON. That means it's very easy to retain control of your data and even go to the extent where you can source control your model, which makes development workflows much easier. Let's go and take a look at LUIS in action over on the demo machine. So to get started with LUIS, we're going to go to the LUIS portal, and it's available at luis.ai. You can sign in and then start building natural language applications. So here's one that I prepared earlier. I'm going to open this up. And I want to show you how easy it is to train a natural language model with LUIS. So the first thing we're going to go and do is have a look at the intent list. And I've built an intent to recognize when the customer asks to purchase insurance. In this intent, the I need insurance intent, I've specified a whole bunch of different ways that customers might ask for insurance. They've got examples like, I want to insure my new car, I want a new insurance policy, I need to insure my car. And to add additional phrases is really easy. All I need to do is type it into this box. I could say something like, I want a policy for my car. I can enter that. And because I've already explained the insurance type entity, it's actually spotted the use of the word car and automatically tagged that as a type of insurance. So that particular utterance is going to work just as well if somebody says, I want a policy for my boat. Now if we go to the Entities tab, we can see the insurance type entity there. It's also present in all of, or at least most of the example utterances that I provided. You can also see suggested utterances once it starts to collect data from end users. The dashboard also shows that kind of information. So I've created the intent, I've added some examples, I've tagged any entities, and not all utterances will have entities. That is an optional feature. Once that's complete, I can interactively work with this model within the portal. So I can say something like, I need insurance, and I can see that appear and match correctly to the I need insurance intent. I could say something like, I need car insurance. And in this case, not only does it match the intent, but car is correctly picked up as the insurance type entity. Once I'm happy with my model, once I've got enough utterances there to be useful, I can go down to the Publish App tab. And I can get started really easily. The first thing I need to do is select a LUIS key, and I can create LUIS keys in my Azure subscription. Once I've created a LUIS key, all I need to do is click Publish, and that then becomes available via a web service that my bot can interact with. Now that's really transparent to us, because if we're using the bot framework, it actually has inbuilt support for LUIS. So any messages received from your users will automatically get passed to the LUIS endpoint. And then you'll only have to deal with the detected intent and any entities. So let's take a look at how that works. We'll switch back to Visual Studio and show you how easy it is to switch over to a LUIS dialog. So if we scroll down to where we receive the message, where we used to have new echo dialogue, we're now creating a new echo Lewis dialogue. And what does an echo Lewis dialogue look like? Well, it's actually really simple. All of the code fits on this single screen. There are a couple of important points to note though. The first one is that rather than implementing iDialog, we're now inheriting from Lewis dialogue. There are actually no required overrides when we inherit from Lewis dialogue. There are no required things to override or implement. So what we've done here is that we've declared a new method called INeedInsurance, and this handles any user requests that match that INeedInsurance intent in Lewis. So if the user types in INeedInsurance, then that will be matched to the INeedInsurance intent in Lewis, and then this piece of code will automatically get called. So the magic here happens in this attribute that sits on top of the method. This magic string that sits inside the intent matches the name of the intent in the Lewis portal. The next thing to notice is the attribute on the class itself. It has the Lewis model attribute. The first parameter is the app ID and the second parameter is the app key. These are both available from the portal. If you want to provide these via configuration rather than hard coding them in your application, you can absolutely do that via the constructor. So let's have a look at the code itself now, and we're going to debug this so we can see it in action. Kick that off. And I didn't have to install any additional NuGet packages here. It's all part of the standard Bot Builder SDK. So let's return to the channel emulator. I'm going to restart this, reconnect to the bot, and I'm going to say, I need car insurance. And we're going to hit a breakpoint. So I'm going to get out from Lewis a couple of things. First, it's going to call the right method. It's correctly identified this particular utterance from the user as a request for insurance. And it's going to include in a collection the entities that it's found. So we can actually search through this entities collection for one that matches the insurance type entity. So here, it correctly identifies the type of insurance that I've requested as car. So this makes it very easy to build natural language processing applications. All the different ways that I could potentially request insurance are obscured from me. They're all managed through the Lewis portal. All I need to do is to be able to handle an intent of a particular name and to be able to search through the entity collections for anything that might be relevant. Now let's click continue and see what happens next. Now, we go back to the emulator, but it's still prompting us for the type of insurance, which is not particularly useful. We need to fix that. So let's return to Visual Studio and see how we can actually take advantage of the type that we've been able to detect. So if we go back to our chain that we built in the last demo, what we can actually do is make this conditional on the information that's been received. So if we receive a type, we actually skip over that first dialogue. If we don't receive a type, then we still run it. And then the continuation that kicks off the next dialogue can actually process that data that we've received, regardless of whether it comes from Lewis or whether it comes from the bot itself asking the user. So let's check that out now. We're going to restart the conversation. We'll say, I need car insurance. We'll continue past that breakpoint, and we can see from the emulator that instead of prompting us for the type of car, it can skip straight ahead and start asking us about the type of car that we're wanting to insure. With that, let's get back to the slides. So that's Lewis. That's a really easy way to add natural language capabilities to your bot. And with that, we conclude our discussion on the Microsoft Bot Framework and building bots in the Microsoft AI platform. Let's quickly revise the questions that we asked at the very beginning of this session. The first one, how do I build a bot? Well, we saw how we can use the Azure Bot Service, which is a mashup of the Microsoft Bot Framework and Azure Functions to both build and host our bots. The next question we sought to answer was, how does it understand the natural language queries that are expressed by my users? Well, for that, we saw just now how we can use LUIS, or the Language Understanding Intelligence Service, to process these in a really easy way. I hope you'll join us for the next session in the AI Developer Bootcamp, where we look at the other language capabilities in Microsoft's AI platform.